potentially flammable lithium-ion batteries are in many electronics, including Samsung phones. The Department of Energy is spending tens of millions of dollars on creating a safer alternative. Jan Crawford is in a lab at the University of Maryland, where one research project is showing some promising results. Jan, good morning.
Well, good morning. So we're here at this research lab at the University of Maryland, where this small ceramic device is replacing the combustible components of lithium-ion batteries. And we got to take a look and see how it held up under fire. So this is kind of like the lithium solution that's in our phones.
Exactly.
Research scientists at the University of Maryland are showing us how they plan to build a better battery, one that can't catch fire. The disc on the left is coated with a naturally combustible carbon-based solution typical of what's used in all of the lithium-ion batteries powering today's smartphones. It is then exposed to an open flame.
That's what happens.
That's what happens.
The problem.
On the right is a lithium-conducting ceramic disc designed in this campus lab.
So it can handle thousands of degrees without any issues.
Because it's ceramic, it is absolutely inflammable. You cannot burn the ceramic.
Professor Eric Waxman is director of the university's Energy Research Center, where nearly 20 projects are being funded by the Department of Energy to find alternatives to store energy.
It's just been a push to get more energy out of the battery. You want it to last longer. You want the electronics to do more. This is not a typical phone, for example, the Samsung. I mean, it's basically a mini computer. You're putting all of that information, all of that processing power in a very, very small device, and you want the battery to also be small.
After Samsung's new smartphone started catching fire, Professor Waxman's nearly 3-year endeavor to create a non-combustible battery started getting a lot more attention.
Has your phone started ringing off the hook?
We've been contacted by numerous companies all over the world, both email and phone.
I mean, where are we now in terms of the development?
So this size is fine for, the little batteries, little coin cells you might see that go into hearing aids or whatever, small little round ones. But to get the larger size, it's just a matter of scaling up the size. This is the cycling back and forth.
But Professor Waxman says a safer battery can and will be mass-produced.
We have manufacturing partners, and we expect to have a product in the next few years.
So right now, you couldn't just say to Samsung, well, we've got it, just start using these. But could we say you're close? Or?
Well, we'd like to say that we have a company, and if they would like to invest, we'd be happy to talk to them.
Because you think this is doable?
I know it's doable.
Now, it's also the goal of these researchers to keep manufacturing these batteries here in the United States. The overwhelming majority of lithium-ion batteries, 85% in fact, are made in Asia. Nora?
Fascinating, Jan.
It's nice that they're doing that.
It is.
Jan, I went to University of Maryland. Didn't spend a lot of time in the science lab. I was at Lido's Pizza. But it's nice to know that the lab is doing the work that it's doing there.
Yeah.
I'm very proud to say.
It's really impressive.
Jan,
it's really impressive.